All right, welcome to The Explainer. Today we're going to take a journey to the very heart of our solar system to get to know the star of the show, literally. We see it every day, of course, but the sun is so much more than just a light in the sky. It's a dynamic, powerful, and honestly, an incredibly complex object that makes all life on Earth possible. So let's dive right in and start our journey to the heart of this cosmic engine.
Okay, first up, let's get a little perspective. You know that ray of sunlight that might be warming your face right now? It actually started its journey from the sun to you exactly 8 minutes and 20 seconds ago. That's the time it takes for light to cross the 150 million kilometers of empty space between us.
It's a pretty chilling thought, isn't it? If the sun just blinked out, we wouldn't even know for over 8 minutes. And then, suddenly, darkness. And our world would start to freeze. That simple fact alone tells you just how critical this star is for our very survival. So yeah, let's get to know our local powerhouse a bit better.
All right, so to really get our heads around the sun, we're going to take a trip. But here's the twist. We're starting from the outside and working our way in, beginning with its fiery, turbulent atmosphere.
So let's look at two layers here. The photosphere, which is the visible surface we see, and the corona, its outer atmosphere. And right off the bat, we hit something that just, well, it doesn't seem to make any sense. The surface is about 5,500 degrees Celsius, but the atmosphere above it, the corona, can get up to a crazy 2 million degrees. How is that possible? How can the air be hundreds of times hotter than the surface it's surrounding?
Yeah, this insane temperature puzzle is genuinely one of the biggest unsolved mysteries in solar science. The leading theory, what scientists think is happening, is that the sun's super complex magnetic fields are somehow funneling and releasing energy way up high in the atmosphere, superheating it in a way we're still trying to fully grasp.
And believe me, this atmosphere is not a calm place. It's a bubbling, chaotic mess. You have these massive explosions called solar flares, and these enormous loops of gas called prominences that arc out for hundreds of thousands of kilometers into space. Then you have sunspots, which only look dark because they're a bit cooler than their surroundings. And all this activity is constantly throwing out the solar wind, a stream of particles that flows past every planet, and it's that wind that gives us those beautiful northern and southern lights right here on Earth.
Okay, so the surface is wild. But believe it or not, that's just the beginning. The real action, the source of all this power, is happening deep, deep inside. It's time to dive beneath that fiery surface.
So you might think the energy made in the core just zips straight out, right? Nope, not even close. It has to fight its way through these incredible layers. First, it bounces around in the radiative zone for what seems like forever. Then it gets to the convective zone, where huge currents of hot plasma carry it the rest of the way. Kind of like water boiling in a pot.
So how long does this whole journey take? Get this. A single photon of light, a particle of light, which takes just 8 minutes to get from the sun to us, can spend, on average, 170,000 years just trying to escape the sun's interior. It's just a mind-bogglingly long and random walk to freedom.
And here's another weird thing. The sun isn't solid. It's a giant ball of super hot plasma that acts like a fluid. Because of this, it doesn't spin like a solid ball. The middle part, the equator, spins much faster than the top and bottom, the poles. And all that twisting and turning is what really tangles up the sun's magnetic field and drives a lot of that violent activity we see on the surface.
All right. We've traveled through the atmosphere, we've gone through the inner layers, and now we've reached the end of our journey inward. We're at the core. This is it. The engine room of the entire solar system, where all the magic happens.
So, every engine needs fuel, right? Well, here's what the sun is running on. It's almost all hydrogen and helium. And that hydrogen, that's the key ingredient. That's the fuel for the fire.
The process that powers it all is called thermonuclear fusion. It sounds complicated, but the basic idea is that in the core, the conditions are so insane that hydrogen atoms get squeezed together so hard they fuse and become helium. And in that process, a tiny little bit of their mass doesn't become helium, it just vanishes. And in its place, a huge burst of pure energy.
And when I say the conditions are insane, I am not kidding. The temperature hits 15 million degrees Celsius, and the pressure is over 340 billion times the pressure we feel here on Earth. I mean, we can't even really imagine that, but that's what it takes to ignite a star.
So what does all that fusion actually produce? Well, the sun converts, get this, 5 million tons of its own matter into pure energy.
Every single second. Just let that sink in for a moment. 5 million tons per second. That is where all our light and heat comes from. That's what powers our entire planet. It's just an unbelievable amount of energy.
Okay, so we've been to the core and back. Now let's pull way, way out and see where our sun fits into the grand cosmic scheme of things. Its past, its present, and its future. I mean, just look at these numbers. You could cram 1.3 million Earths inside the sun. When you add up everything in our solar system, all the planets, all the moons, asteroids, everything, the sun still makes up 99.85% of all of it. We're all just cosmic dust bunnies floating around this absolute giant. But here's the kicker. For all its power and size here at home, our sun is, well, it's pretty average on a galactic scale. It's what's called a G2 class yellow dwarf star, and there are at least 100 million other stars just like it in our Milky Way galaxy alone. It's special to us, for sure, but it's not exactly a cosmic superstar.
And just like us, stars are born, they live, and they die. Our sun is no different. It was born about 4.5 billion years ago. Right now, it's a stable, middle-aged star, which is good for us. But in about 5.5 billion years, it's going to swell up into a red giant, getting so huge it will literally swallow Mercury and Venus. After that, its outer layers will drift away, leaving behind just a hot, dense core called a white dwarf.
So, when you put it all together, the sun is this incredible paradox, isn't it? It's our life giver, the source of everything we have. But it's also got this violent side, with solar storms that could seriously mess with our modern tech-heavy world. And that kind of leaves us with a big question to chew on. As we become more and more reliant on technology, how do we keep living safely with such a powerful and sometimes unpredictable next-door neighbor?